Okay, so here we have same instructions, new coordinate, and -4 we know will be over here somewhere, right? Because x value of -4, and then the square root of 2. It's a little more than 1, but we're just gonna, since we know it's positive, we're just gonna represent our point there. Okay, so our theta was coming from r, or from the origin, right? And we are at -4 square root of 2, which means our this side of our triangle is going to be -4, and this distance is the square root of 2. Now, I know many of you, your geometry teachers would have smacked you if you wrote -4 down as a side length, because distance is never negative. However, because of the work we're doing, because we're existing in the coordinate plane and direction matters, we're going to leave that negative. Okay, it's not a negative side length, but it tells us the direction we moved in order to get that value. So we know that x is -4, y is square root of 2, and r, well, we don't know r yet. So same idea. The sum of the square of the legs is equal to the square of the hypotenuse. So we'll have -4 squared plus square root of 2 squared equals r squared. -4 squared is 16. Square root of 2 squared is 2. So we get 18 equals r squared, which means r is the square root of 18. Okay. All right. Square root of 18 will simplify because it is the square root of 9 times the square root of 2, which means it would be 3 square roots of 2. And we like to use the simplified radical versions wherever possible. Okay. So we know that r is 3 square root of 2. Okay, so now we just have to go back and find our trig ratios. Okay, so we want to get our trig functions, our exact values, right, written down. So we're going to set up the ratios. Sine theta was y over r, so that's square root of 2 over 3 square roots of 2. And then we simplify. Square root of 2's go to 1, and we get 1/3. All right, cosine theta will be x over r, so -4 times 3 square roots of 2, which we do not like to leave radicals in the denominator, so we multiply by square root of 2, and we end up with -4 square root of 2 over 6, which we can further simplify to -2 square root of 2 over 3. Then tangent theta will be y over x, so that's square root of 2 over -4, or simply negative square root of 2 over 4. Okay, then we would have cosecant theta being the reciprocal of sine. We'd write 3 square roots of 2 over 2 square root of 2, which again, square root of 2 divided by square root of 2 is 1, and we end up with 3. Then secant theta will be the reciprocal of cosine, so we'd have 3 square root of 2 over -4, or simply -3 square root of 2 over 4. And then finally, cotangent theta, being the reciprocal of tangent, will be -4 over the square root of 2, which again, we don't like to leave radicals in the denominator. So we'd get -4 square root of 2 over 2, which further reduces or simplifies to -2 square root of 2. Okay, so let's take a look at another problem that we could solve using this information. And again, let me go to 3 instead of 4. That would be more helpful. Okay, so if we have sine theta is equal to -5 over 13, and theta is located somewhere between 3 pi over 2 and 2 pi, then I know 3 pi over 2 was here and 2 pi was here. So somewhere in this area is where my terminal side's going to be. Okay, so somewhere I've got to be able to figure out some more information. So let's think about what we know. Sine theta is also, remember the ratio was y over r. So y is 5 and r is 13, except I've got to deal with this negative. Either went with the 5 or the 13, but we know that r can never be negative, so it must go with the 5. Okay, so now we have to figure out, well, what's x? Well, if you'll recall, we have our right triangle going on, so x would be this value, y is negative 5, and r is 13, so we can say that x squared plus negative 5 squared equals 13 squared. Okay? Which means that x squared plus 25 equals 169. So x squared would have to equal 144. So x would equal 12. Okay, and so looking here, we're going from the origin to the side, so x would definitely be positive 12. Okay. All right, I'm going to erase some of this work so that we can have a little more room. And I've got everything labeled over here, so I don't need this anymore. And now we can set up our other ratios. So we know that we already know sine theta, so we need to pick up cosine theta, which is x over r, so that's going to be 12 over 13. Tangent theta is going to be negative 5 over 12. Cosecant theta will be r over y, so that's going to be negative 13 over 5. And then secant theta will be the reciprocal of tangent, so that's going to be 13 over 12. And finally, cotangent theta will be the reciprocal of tangent, so that's going to be negative 12 over 5. All right. All right, so last one. Find the exact values of the other 5 trig functions for an angle theta in standard position given the following. Secant theta equals negative 2. And theta is located between pi and 2 pi. So I'm going to approach this like I did the last one. We're going to set up our grid and do a little sketch and thinking. So secant theta was our r over x, or was it r over y? Secant, was r over x. Okay, so double checking that. All right, so r over x, and so that means it would be negative 2 over 1. But r can't be negative, so r would be 2, and x would be negative 1. So if I'm doing my sketch, negative 1's over here, this direction, r is going to come down here, that's going to be my 2. I've gone a negative 1 distance, and I don't know about y. Okay, so I use Pythagorean theorem again. Negative 1 squared plus y squared equals 2 squared. So 1 plus y squared equals 4. Y squared would then equal 3. So y is the square root of 3. But because I had to go down to get to be in the right place based on where theta was located, it should be negative square root of 3. Okay, so I need to know the other 5. I've already got secant, so I'm going to find sine theta, cosine theta, tangent theta, cosecant theta, and then cotangent theta. All right. So if we're setting these up, sine theta is y over r, so that's going to be negative square root of 3 over 2. No simplification needed there. Cosine theta would be negative 1 over 2. Tangent theta is going to be y over x, so that's going to be negative square root of 3 over negative 1. And so that's going to actually just be square root of 3. Okay, cosecant theta, cosecant goes with a sine, so we're going to do the reciprocal, so that's going to be 2 over negative square root of 3. We'll multiply both by the square root of 3, and we get negative 2 square root of 3 over 3. And then cotangent theta, we're going to do the reciprocal of tangent, so that's going to give us negative 1 over negative square root of 3. So we multiply by the square root of 3, and we get negative over negative is positive, square root of 3 over 3. Alright, so that's how you use your sine functions.